So our next presentation is by Matt Green, also a member of the Velociraptor team here at Rapid7. His presentation is Notebook and VQL Data Munging, Your Way to Victory. And for those of you that don't know Matt, he is our principal engineer here at Rapid7 on Velociraptor. He is an endpoint and threat-focused practitioner, and he has been an early adopter who's been working with Velociraptor since version 0.2. And Mike and I were talking about this with Matt the other day. Mike doesn't even remember version 0.2. That's how long Matt has been with us. So he definitely comes with a tremendous amount of knowledge and experience with Velociraptor, and we're really excited to see what he has to say today. So Matt, if you don't mind, take it away.
Sounds good. Thanks, guys. I'll just share my screen, so bear with me while I figure this out. Can you see that okay, Carlos?
Looks good.
Awesome. Okay, so yeah, my talk today is about Notebook and VQL, data munging your way to victory. The agenda today, I'm going to give a bit of a background. I'm going to then focus on some examples. And again, that's going to be focused on some of the gaps that we see. And it was really awesome to have Mike lead in, because this talk is kind of an intermediate level. So the assumed knowledge, Mike has just explained everything. So that makes it really easy for me. I'm then going to cover some practical application, and that's where we start to get really complex. And for me, it's usually I do demos and stuff for the practical side, but I wanted people to be able to see the VQL. So this is a new thing for me. So I apologize in advance if the VQL doesn't show too good, but I think it looks okay. So we've only got about 30 minutes, so I'll get into it. And these slides will be available afterwards. And I'm also sharing some artifacts, and I'll share some notebooks as well. And I'll throw the links in the slides. Okay, so what is Velociraptor? Now, Mark's covered this off pretty well, so we'll skip ahead. But this slide I wanted to cover off was the architecture. The architecture I'm covering off today is a server-client model. Most of the stuff in the workflow I'm talking about is focused on essentially optimizing this workflow here. And I've seen lots of other people start to do like WebExes and things like that. And a term that I've coined a while ago is live response. And that's essentially the concept of collecting rows from the endpoint and then doing some analysis on that, and then pivoting and repeating really fast. Of course, we can collect raw artifacts, we can process them in other tools and then bounce to other tools as well. But for the most part, if I'm doing an IR, I'm really only doing that for preservation, and then if I need to answer specific questions. It's all about speed with Velociraptor. And just like that guy in the picture there, it's awesome when it works. Right, so here's some links that I'll share, and I'll bounce through this, but these are available. And I've also got some extra links down the bottom. But to start this kind of workflow, it all starts off with the collection, right? So the picture on the screen, I'm running a hunt. I'm selecting my artifacts. In this case, I'm focusing on ASAP, so auto runs and start items. But the point I wanted to cover with artifacts in general was typically we write them to be either very targeted, or the ability to add filters and things. So you can do like IOC-based use case, so your collection is very limited, or we make them to be able to collect more. So in this one, we're essentially just looking at run key globs, but it's that concept that I try to get through all of our artifacts that I think is really special with Velociraptor, and it doesn't limit the user into like predefined rules or predefined detections that a vendor gives you. You can kind of expand and write your own as well. To access Notebook in a hunt, funnily enough, you click the Notebook tab. So it's really simple to find out where we want to go. But essentially every collection item in Velociraptor has a Notebook tab. So I just flicked here, and now we're looking at the standard collection, the flow view, where you get a little bit more information. We also have it in monitoring view. There's also a separate notebook section where you can build notebooks and start plugging away. And in fact, most of the talk that I have here today was created in this view. So it's really handy for manipulating data and just presenting things. The magic happens when you click on that little kind of pen icon. And you can see on the screen, I've got the results for my auto runs hunt here. Again, you just get the VQL view and then you can start going to town. The goal of Notebook is essentially presentation and data reduction and post-processing. So how I generally explain to people is you're going from a lot of rows down to the rows that matter, and also focusing on kind of seeing the data that's important in a way that triggers with you. So the first thing I wanted to cover is a really simple use case, and this is called the column filter capability. And the reason why I'm covering this is it's been around for a while, but I never see anyone use it except for Mike and me. And it's really awesome. You simply click on the end to get a list of columns, and you filter down by selecting. This is an amazing capability for just a quick screenshot if you need to add to a report or if you need to export to CSV. The caveat here, though, is when you refresh data, it adds the fields again. So it's not a permanent kind of view pane. So it's great for, like I said, just taking those screenshots. The next section I'm going to cover is we're going to start to get a bit more technical. We're going to start to look at enrichment. And on the same theme of that collection I ran before, we're going to look at enriching auto runs data and kicking off that low-hanging fruit kind of detections. What I see in terms of enrichment is generally it's going to be reputation checks. It's going to be things like geolocation or other contexts. And the technique that I'll show you here, I'll use it throughout, and hopefully you'll see the theme that I'm adding where I'm constantly enriching for performance and things like that. Some considerations with what I'm about to show is I'm actually trying to improve performance, because often when you do a large hunt, you may have a lot of data. And the other thing that I've noticed that people have been sharing is a lot of the open source enrichment is rate limited. So in this case, I'm using an internal artifact that is not rate limited. And essentially it's the same concept as another artifact that you might use, like geolocation or something along those lines. Now here is the notebook that I use for this, and it's all squashed together to fit on a page. So I apologize for that, but essentially it's in 3 parts. The first bit is materialize the collection. So in this case, I am looking at essentially pulling out the fields that are going to be useful to me, and also kind of changing the names of them to be stuff that I can remember. So I pull that out and I use the materialize command here, which people may not know. Essentially what this does is it adds all the rows to memory, so it's very fast to look it up again in the future. The second point I'm going to do is process all unique hashes. So I generate unique hashes here by, again, using that all entries parameter, and I'm pulling out all unique SHA-1 values from here. I'm then applying it to my enrichment artifact by SHA-1, and I'm looking for all the entries that are flagged as malicious in our database. Finally, I'm using 100 workers, and this is so I can throw a lot of queries quickly and have it finish in a timely manner. This is really interesting. This database has like a good list as well, so you can use it for lots of things. But for this use case, it's really, really handy. Finally, I roll it back, my hits back into my all entries and enrich the output. So you can see here, I'm just manipulating the fields that come back. I'm also hiding client ID. And that's an interesting feature in terms of, from a presentation viewpoint, you won't see the client ID, so it will be a lot cleaner to the user. And what it will do is it will then enable us to be able to use client ID later for enrichment. And here's the results. It is quite a good view here. And this is pretty fast as well. Really, really handy. I actually ran this at a customer the other day, and I had 3 hits. It's a really good first check to find that low-hanging fruit in the environment. Okay, so the next thing I'm going to talk about is labels and how to add them. Most people I see will add a label in the VQL itself, and that's good. That works really well. But when you're talking about really big data sets, that doesn't work too well, because you don't want to reprocess, right? So what we can do, and Mike touched on this before, so it's reiterating what he mentioned, is we can add cell from cell. And what that will do is that will spawn kind of like a results notebook for us that we can then add our processing to. And I'm going to show a really cool use case of doing this with monitoring later that I think people will get a lot of benefit from understanding. The next thing I need to touch on is regex. And regex is so important to Velociraptor. Almost everything we use regex for. So that's from function parameters to artifacts to filtering. I need to bring it up and I need to kind of explain it a little bit here. First of all, it's case insensitive. I'll be covering the functions that are listed there in the middle. Regex replace, transform, and select string from regex. But it's also worth talking about some new features to 6.6, and that's any and all. I'm not going to be covering these today, but essentially they're new functions that will enable us to do things like tokenization. So if you are interested in following up some of this stuff, check out 6.6 and check out the any and all to do interesting detection use cases. It will really help, I think, with things like sigma rule conversion and stuff like that. Okay, so keeping on our ASEP kind of theme, right? I wanted to kind of show something that people often filter out when they're doing kind of analysis of auto runs type stuff, right? So you can see what I've done here is I've created a filter searching for OneDrive. I've then stacked based on the name, the path, and the details. The thing to point out is regex here is double escaped, and that's something that might confuse new users to Notebook, in that you typically escape regex in Velociraptor, but then in Notebook you need to double escape, which can be a bit confusing, unless of course you use triple apostrophe to encase. You can see at the bottom we've got about, what's that, 1,150 entries. So there's a really big tail, and that's because of lots of unique SIDs and things like that. This is actually real data that I've kind of anonymized by changing SIDs and users and things. So it's a real world use case here. But we solve this by using regex replace to normalize. And you can see what I've highlighted here is I'm using HK users with a SID regex, and I'm replacing it with user drive. Down the bottom, we've managed to normalize down to about 400 entries, but this time we've also got the details on the other side, which are the users. So again, we can normalize that. And in this case, we can use another regex replace, but I thought I would introduce the regex transform function, where effectively we can have multiple regexes and transfer and transform data. In this case, I've got the same one as before, but I'm also adding a user path transform as well. The software there is actually to change case as well for software. And you can see the malicious file pops out like a sore thumb in that case. And this is classic data stacking. It is a really easy one to run. In the real world, I might have like 10, 20, 30 of these and build out these transforms as I go in Notebook. And it's just a really easy way to manipulate data. And if you've got regular transforms that you might want to run, just keep a copy of them and roll them in and deploy them every time you do analysis. It's super easy. Okay, so the next thing I need to cover is data types. Mike touched on this a bit, but there's so many new types in Velociraptor. This is just a subset, but I wanted to cover this to show a really good troubleshooting method in Velociraptor. Now, what you can see on the screen is essentially some kind of actions with different types, right? So the first one is working. It's just adding a string and it's working fine. The second string and an int, it's returning no results, which might be unexpected. You can see array and path is working. Path and array, it's leaving out the integer. And then you've got some floating and integer adds there, which the last one could be unexpected. Now these are okay, but often when you're writing complex VQL, things might not work as you expect. And essentially you save time by using the format command and printing out the type. And this is something that I share it with lots of people and no one uses it, but it's always the last thing you try after spending a couple of hours banging your head on why something's not working and you found an edge case. So use this and you'll be extremely happy. Okay, so the next thing I'm going to show is a forensic use case, and it's extracting and combining multiple messages in event logs. This use case I've seen a fair bit where you might have a encoded binary in the event logs. The use case I have here, Cobalt Strike wasn't running, so we couldn't see what the config was in memory, and we found it in the event logs. But I wanted to extract that. People will often, copy and paste base 64 out manually and have a tough time. But I want to show how we can do that in a few seconds in Velociraptor Notebook. So the first step is essentially we're going to be querying for our items of interest. And in this case, I've used Glob, searching for PowerShell. And this is the most efficient way to hit PowerShell logs if you're going to be using the EVTX Hunter artifact. The second thing I do for performance is I box time around the alert, looking for the time that I'm interested in. And the third thing is I obviously hit my ISCs. And in this case, it's all, but I am looking for a event ID of 4104 for script-block logs. Okay, so the results that we have are, well, 3, but 2 of them are really interesting. And I think it's worth kind of pointing out kind of how script-block works in PowerShell, where effectively you'll have some encoded PowerShell transverse the script interpreter. It's then decoded, and then the decoded code is put forward over the script interpreter. So what typically happens is you'll get kind of 2 logs or sometimes a lot more kind of versions of the same code. And that's essentially what we saw here. And you can decode the first lot, but my recommendation is to cheat and start at the second and skip the first line of decoding. Let Windows do it for you. That way you can at least get down to the binary part, because the way PowerShell works, it doesn't decode binaries, and you just get down to the reflective loading where it loads the binary in memory. And it's a super, super easy way to kind of fast forward. So what we can do to find our script-block logs is Notebook, of course. And I'm using the filter of the script-block ID. I was just looking at this on an individual machine, but you could also put in other fields like computer name or the event log number and so on and so forth. But you can see when I run this notebook, in the bottom left-hand corner, I've got 21 messages that are popping. So we're spot on there in terms of what we're pulling back. The next question is, how do I get the payload out and combine them? And to do that, we use the join array. And essentially I've highlighted, and we're talking about the one at the bottom, where I'm joining payload.scriptblock text, and I'm using no separator, and I'm calling that payload. And then I'm also adding messages, and you'll see why very soon I'm doing that. The other thing to talk about is I'm using the first item in each of the other events, and I'm doing that because they're all the same, so it's fine just to use the first item here. But this is what happens when I run that, and it's really cool. I joined the messages so I could validate that I was actually getting all the messages that are relevant. So you can kind of see we've got 1 to 21 there. That's in the right order. So that means my payload is correct. And obviously I've cut that off. It's much, much longer. So that means we've successfully joined our PowerShell together. So the next question is, how do I decode it? And how do I get what I want out of it? So what I typically do is I'll create a dynamic function here. So the top function is called function. And what it's doing is it's just removing the base 64 and returning the PowerShell bit. And the second section in the middle is a dynamic function that will extract the base 64 blob called base 64, funnily enough. And then the VQL at the bottom, I'm doing the exact same thing as I was doing on the last screen, but I'm just running it through those functions. And you can see this is the result of the function. It definitely is Cobalt Strike. You can see that. But it's also giving us the hint of what we need to do to decode it, right? So you can see the base 64 there, but you can also see the XOR with the decimal 35. And you kind of know where this is going, right? We actually have an XOR function in Velociraptor. And you can see I've used the format command here to create a decimal representation of 35. And then I've piled the same base 64 function into the XOR as the string parameter. What I do is I take the results of that and I then kind of pipe that into Cobalt Strike. So Mike mentioned the Cobalt Strike artifact. It's pretty awesome in terms of carving. There are some nuances to using it, but that's another talk itself. But I'm also doing a little bit of presentation here. And you can see the presentation. Hopefully you can view this okay. On the left-hand side, we've got our message details and validation. The middle bit, we've got the payload. So I've got the function, the base 64, and the payload itself. And you can kind of see the MZ header there standing out. And on the right-hand side, we've got the Cobalt Strike config, which is really cool. For this actual use case, I just kind of generated data by literally using the Cobalt Strike jump command and hitting a box. So it's kind of straightforward and easy. But once you've got the data, it's really easy to decode. And even if they're using something exotic, you can just change the XOR config. You've got Velociraptor is pretty much a coding language that you can decode. Mike also brought this up as well. Right click in 6.6. If you wanted to copy the binary, you could copy it to clipboard and then send it to CyberChef. One caveat with this feature is there is a GET request limit to CyberChef, so you can't throw up like a megabyte or 2 megabytes of file, so you need to use the clipboard for that. Okay, next section, ETW and PowerShell monitoring. This is something I've been working on lately, and it's really cool, and it plays into the theme that Mike was talking about as well. As we know, PowerShell is commonly abused by threat actors, and most detection is limited to command line. The big gap that we have is we don't see script contents or things that are typed on the shell, unless you've got like read line or you've got other kind of artifacts. But for the most part, we don't have monitoring on command line, which is what everyone's looking at in EDR. The challenge with this stuff, though, is finding useful things in the noise. So I thought I'd walk through how I kind of create a monitoring artifact that people could kind of copy the same methodology. So in this case, I'm not going to walk through all of ETW. It's a huge topic, and I have a link on it here. But essentially, I use Web Explorer to find what I'm interested in. In this case, it's easy. PowerShell is pretty well known. I find the PowerShell GUID here. But you can also find keywords for performance filtering and things like that, and also look up event searching and stuff. So that's kind of straightforward. But what I do is I will enter my GUID just with a select star to kind of pull back everything. And then I'll generate an event that's easy to trace. So in this case, you can see I've just done right host testing event generation. Once I generate some events, I hit stop. And then I do that same trick that we talked about earlier, where I add cell from cell, so I can get and start my munging process. Here you can see the only thing I'm adding to the notebook is I'm pulling out the events I'm interested in, but I'm also adding a where and looking for right host. The results from doing that really shine, right? So you can see 4104, that's the script log event ID. That's really useful. And you can see the valuable data, exactly what I typed. And then the other event log is 7937, which looks like some kind of module logging here. And you can see in the bottom of that big highlighted square, we've got the right host is started command there. So we know what we're looking for if we want to kind of collect this info. So you can see I'm going to run the exact same notebook I ran before, just adding that line at the top where I'm saying, hey, give me all of the event IDs, 4104, 7937, but filter for events with a script block and filter for those module start events. So we're being very specific in what we collect. The second thing I'm going to do is I'm going to take the results of those hits and I'm going to add a payload field that's dependent on EID. So 4104 is pretty simple. We're just grabbing the script block text. For the other event log, I'm essentially removing the command and his started bit, and I'm just going to have the module name, right? And then for the second part down here, I'm parsing context info, so it's no longer a big binary blob. And hopefully you can see the same functions I'm using here with the ones that I showed at the start, right? This is the core of writing artifacts. So if you are interested in playing around, learn these, copy and paste to get up to speed with them. But once you get regex rocking and rolling, you'll be able to write some super amazing artifacts. The results of that notebook is here. So it really looks like useful information that we might be interested in. The question is, how do we turn this now into a detection, right? How do we turn it into something that's useful that we can use for security monitoring? And the answer is what I showed before, the kind of enrichment style, that way of thinking. I've created an artifact and I literally pushed it to the artifact exchange when Mike was talking. And I use CSVs a lot. And I'm going to show you how I do that. Essentially, I've got parameters here. And you can see I've got my ignore paths at the top, a path as well as process name ignores. And then down the bottom, I use this CSV to define collection. And this is just for my demo. I've only got a few. I deploy this in field and just collect. I'm still at the POC stage, so I'm not really confident to deploy it 100%. But it's really useful and it's showing lots of promise here. So the strings I'm monitoring for is do it and the XOR of Cobalt Strike, as well as get process, get service, and write host from a commandlet loading. The next thing I'm going to do is essentially show you the VQL here. So very similar to before, I'm materializing what's needed for performance. So in this case, it's my detection logic. I'm materializing all the detection logic and all the ignore things that are going to be hit on the first pass, right? So you can see here, we've got two kind of types, one for script block, one for commandlet, and then also the script block ignore path. We actually use that on the second pass, but nevertheless. Secondly, I'm going to apply that first pass filter detection. So this is exactly the same VQL as what I ran before testing. I'm just adding in the filters for that first path. And then if you think we've got all of those rows that are all the juicy things that are interesting, we then do the same thing and do enrichment, which is really cool. So in this case, we do for each hit. In this case, we're calling our IOC CSV, and I'm doing things like process chain enrichment. So what Mike showed you, and I'll show you that in a minute. I'm doing things like the second pass filtering here, where we start to use the CSV and do specific filters. And there was an ignore list in the filter as well. And we also start to enrich the results that come back. This is me deploying it, so it's quite easy to deploy. If you want to have a play with the artifact, I pushed up to the console. And this is the results. So at the bottom, I did a base 64 encoded command that was get process, out now, and then write host testing script block detection. You can see it's detected the payload. I actually included the command line like this, although we still would have detected if I typed it in a shell, just so I could show off the process chain output. I'll probably end up changing this to look more like Mike's one, because I think it's probably a bit easy to see, but we've got all the parent-child hereditary process chains, which is super cool for a response capability when you get a detection. The next thing I'll show is the Cobalt Strike side of the shop. So looking at script block logs. Here I've just done a simple PowerShell PS exec. And this is what I was talking about in terms of having two events, right? So the first event, you can see there's an IEX here. And then the second event, same thing, but without the IEX. So it's that second run over the script interpreter. So this capability is very, very exciting. And there's lots of nuance here for improvements and getting some really, really cool detections happening. As I said before, it's great at filling that console or script visibility gap. The issue is the noise, but we need to test it. We need to make sure it works. So I put the artifact on the exchange, and I really ask people to go out and test and provide feedback, and let's get this thing going really good. I've included that link to the blog that I was talking about from NASBench. It's a really awesome blog. And if you are interested in ETW, not just PowerShell, anything, take a read of it, learn the techniques, and then we can build some amazing monitoring artifacts for Velociraptor. I think we're coming up to time. So I think that was pretty good timing, actually. And just to wrap up, Velociraptor, it enables the collection and manipulation of data at the endpoint. Like, all I've done is kind of step through different things, different data I've collected. And that's what Velociraptor is, either in the notebook or when you're writing artifacts. And pretty much anyone can do it. VQL isn't a difficult language. You just need to take the little steps at a time and work your way through queries to get answers. There's lots of more things that I have left out. We could probably do weeks of training and still not cover everything. But as I said, start small, start with those small increments and build from there. Finally, another link for the learning. And again, I'll be sharing all this stuff. But that's kind of it, guys. Thank you.